Thank you. Additive manufacturing for production provides huge benefits. This is a fuel nozzle, and it's additively manufactured using cobalt chrome, and it is part of GE's LEAP engine. Production of this fuel nozzle has already begun, and by 2020, GE expects to manufacture 100,000 fuel nozzles each year. But the real question is, how did GE manufacture a fuel nozzle using additive manufacturing? Well, it all starts with design. And material property data is needed to design parts. Now, normally, you would consult handbooks and material databases if you wanted to look at material property data. However, handbooks and databases simply don't exist for additive manufacturing materials. And why? It's because additive manufacturing is extremely complex. It's complex because the material properties are highly dependent on how you make that part. And is dependent on factors like what machine you use, or what parameters you use, or what are the characteristics of that feedstock. In fact, there are hundreds of variables, each with different sensitivities. And what that means is generating this data is extremely expensive. And it's expensive because you have to run a lot of tests in order to get a data set for an additively manufactured material. And so, given that additive manufacturing is very complex and it's expensive to generate this data, if you're a company and you're thinking about adopting additive manufacturing for production, you really have two choices. Number one, you can spend time and money to characterize the additive manufacturing materials yourself, or you can just choose not to adopt additive manufacturing for production. And GE chose number one. They spent enormous resources characterizing the cobalt chrome material used to make that fuel nozzle. Now, what was happening in the industry was that a company like GE was spending time and money to collect the data that they needed. And then company number two was doing the same thing. And company number three was doing the same thing, and so on. And so, in fact, all of these companies were actually characterizing the same material and doing it in very, very similar ways. And what that did was that because it was so expensive to characterize that material, they couldn't share that data with each other. It was competitive information. And this duplication of efforts created an opportunity for Senval, my company. So instead of all of these companies characterizing their own materials, Senval would spend time and money to characterize the material, develop a data set, we would own it, and then we would sell it to all the companies that need it. And we could do this because we understood the complexity of additive manufacturing. And we were essentially developing the same data set that these companies would have developed for themselves. And our business model is simple. We sell the data set to multiple companies at a fraction of the cost of what it would have been for each company to develop that data set themselves. So going back to the two choices, if you were number one and you were going to spend your own time and money characterizing that additive manufacturing material, instead of doing it yourself, you can buy a data set from Senval. And that could save you a lot of time and money. However, we still have a lot of companies that chose number two. In fact, there are a huge number of companies that simply don't have the resources to devote to characterizing additive manufacturing materials. And Senval serves these customers as well. In fact, for example, the cobalt chrome material that's really useful for designing jet engine fuel nozzles is also really useful for designing gas turbine components and dental implants. And by doing this, Senval has created a way for any company in any industry to have access to additive manufacturing data. And that's because it is significantly cheaper to buy the data than to develop your own data set. GE is already harnessing the benefits of additive manufacturing. Senval's product has created a way for any company to have access to data that they could use to design parts for additive manufacturing for production. So, in conclusion, the complexity of additive manufacturing meant that characterizing materials and obtaining that data set was extremely expensive. And because it was so expensive, companies could not share that data with each other, which created a duplication of effort. And that duplication of effort created a market opportunity for us. And our product, we address that market opportunity because we understand the complexity of additive manufacturing, and our business model has eliminated the duplication of efforts. And as a result, finally, Senval is enabling the mass adoption of additive manufacturing for production. Thank you.